Assalamualaikum and good day. This time I talk about chapter 9. It's centroid. My name is Mustamri Mejana, Faculty of Mechanical Engineering, New Steel Technical Malaysia, Melaka. What is centroid and where is the application of the centroid? Here is a few types of beam we are used in building construction. If you look at this beam, we have many form of the cross section area for the beam or the concrete. So where is the area centroid for the beam? Where is the area centroid for the beam cross section? Because we need to determine the centroid location of this beam, because we need to do the analysis, the strength and the stress of the beam. Another example of the application is this American football goal pole. So where is the line centroid for the goal pole? Because we use the centroid to do the stress analysis to determine what is the deflation of the beam, what is the highest stress of the structure. It's either pole, spine, beam, and etc. So by knowing the center of this structure, we can determine the stress, the maximum stress, the location of the maximum stress, and the strength of the structure. So this is the application of the centroid. So one of the method for determine the centroid is by analyzing the composite body. The composite body is a series or simpler shape of body consisting of the few simpler body such as circle, where it has center of gravity or centroid at the center of each circle. Rectangular, where it has the centroid point at the center of its shape. And then we have triangle, where it has the centroid location at 1/3 of its left side and bottom side. And semicircle, where it has centroid point located at the middle of the semicircle, and the height is 4/5/3 distant from the bottom side of its shape. So this is simple shape of body where are combined together become a composite body. Again, to determine the central equation, we can use or we can apply the equation of the center of gravity, that is the location of S bar. This means the centroid at the S direction is equal to the summation of the W S bar over the summation of W, where W is the weight of the body, or either is the area, the volume, or the line of the body. So similar to the Y direction, the Y bar is equal to the summation of the WY bar over the W summation of W, and Z bar is equal to summation of WZ bar over the summation of W. So is S bar, Y bar, Z bar is the central coordinate for the whole body, and then the S, Y, and Z bar is central coordinate for each part of the composite body, and the total of W is summation of W is total weight of the body. To do the analysis, the procedure for doing the analysis, for example, we have the complex shape of body. Okay, we have two circle, a rectangular and a triangle. What we need to do the analysis, first, if you look here, we need to draw a line of as a reference, the line of the coordinate system XY. If not given, we need to determine where is the axis of XY and the cross section of the X and Y axis. The first step, we need to divide the body of the composite body into simpler shape. For example, here we have circle hole 1. The small hole that made the circle that made a hole for the composite body. Second one is the big circle. Okay, the blue one is the body, and the third shape is the rectangular, and the fourth shape is the triangle. So we have divide the composite body into 4 shapes, where is the first shape is a whole. That's mean because if the part is a whole, we consider it is part of the body with negative weight and size, right? Jadi this mean the area or the volume or the weight of the body must be in form of negative because it is a whole. Next, determine the weight of the body W or the area or the volume or the length. In this case, the example that I given here is about the area. So we need to determine the area of each part. So we have 4 parts here. So we need to define the area of A1 is seen is a whole, so it's negative A1. The area of A2 for the circle 2. The area of A3 for the rectangular 3, and the area of A4 for the triangle 4. So we have 4 areas here. Next, we need to determine the moment arms. The moment arms means the length of the centroid point for each part. So it is coordinate of S bar, Y bar, Z bar for each part. So here, what we call the moment arm consists of S bar and Y bar. For the first hole, the circle, we have here S1 and Y1. This coordinate, so it depends on the location of the S and Y axis. Is either in positive side or in negative side. If it is in negative side, so we need to put the negative value. If on positive side, we just put as positive value. So in this case, we write down the S1 and Y1 bar. For the circle 2, we have S2 and Y2. The coordinate of S2 and Y2. For the rectangular 3, we have S3 and Y3, and for the triangle 4, we have S4 and Y4. This is what we call the moment arm. This is the distance that we are going to use to determine the moment. Okay, because if you know that the moment is equal to force or the weight of the body times with the perpendicular distance, that's why S and Y is what we call the perpendicular distance, is what we call the moment arms. Next, we calculate the moment for each part is the equivalent to the area A. For this case, it's area. Okay, times with the moment arms. What we have here, okay, we just for the circle hole 1, we have got minus A1x and minus A1y for each direction, say the in S direction and Y direction. And similar for the others part, we have X to S and A to Y. For the rectangular 3, we have A3 S3, A3 Y3, and then the triangle we have A4 X4 and A4 Y4. So we done the second step of the moment arms. Next, for the third step, the summation. What we call the first one, we need to sum up the total of moment and the weight of the body. In this case, is the total of area A. Alright. So first, we calculate the total of area. There is minus A1 plus A2 plus A3 and plus A4. This is the total of area. And the total of moment, so we need to sum up the total moment in S direction. We have A minus A1 X1 plus A2 X2 plus A3 X3 and A4 X4. So this is the total moment in S direction. And similar to Y direction, the total moment in Y direction is we have minus A1 Y1 plus A2 Y2 plus A3 Y3 and plus A4 Y4. And finally, we could determine the central location of the whole body is by using the formula of the central. For example, S bar is equal to the total of the moment divided by the total of the area. So we have equal to minus A1 S1 plus A2 S2 plus A3 S3 plus A4 X4 over the total of weight minus A1 plus A2 plus A3 plus A4, and we get the answer. Similar to the central for in Y direction, we have the summation of the moment in Y direction divided by the total of area. And that's all about the centroid. And thank you dan selamat maju. Jaya.